Good morning. We're going to continue talking about pressure. We've talked about fluid pressure, pressure in water, pressure in liquids, pressure in air or gases. We've talked about recently buoyancy. That's what we used in the Flinker lab. Remember, the buoyant force is a force that opposes gravity. You put something in a fluid. There is a push upwards from the buoyant force that acts against the force of gravity depending on the density of the material. You're playing with the density of your Flinker, trying to get something that had approximately the same density as water, so it would hover in the water. But now we're going to move on to another change in fluid pressure, or another phenomena that causes a change in fluid pressure, and that's Bernoulli's principle. Okay? So to recap, the things that we already know change pressure are heat, the volume of a container, and the number of particles in the container. So remember that pressure is a force caused by collisions on a surface. And when I say heat, volume, and particles change things, that means if we increase heat inside a container, we will increase the pressure within that container. If we increase the volume of that container without changing heat or anything, we'll actually decrease the pressure. So all the same particles, but in a larger space, not less pressure. And then if we increase the number of particles inside a contained space, we'll also increase the pressure. And the reverse of all those is true. All right? But Bernoulli's principle is going to be a slight change, a change in how things move that will create a pressure difference. So please, in your notes, just write down Bernoulli's principle, and I want to talk about what it is. All right? So what is Bernoulli's principle? It's responsible for a lot of interesting behaviors, like this ball that's not quite above that jet stream of water. It's a little bit off to the side, but for some reason the ball is staying up in the air. Well, that's going to be explained by Bernoulli's principle. So in your notes, let's write down that Bernoulli's principle states that as the speed of a moving fluid increases, the pressure within that fluid decreases. Right now, I'm surrounded by air that's not moving very fast. All right, all that air is moving about the same speed around me right now. That air all has the exact same pressure. But if some of the air were to move faster than the rest of the surrounding air, the pressure inside that air will decrease. There's a lot of different ways we can visualize it, but it's going to explain things like why a plane is able to fly, or at least one of the reasons a plane is able to fly. What is the force that lifts an airplane up? Well, Bernoulli's principle has a lot to do with that. But it is all about the speed of a moving fluid. All right, so the faster a fluid moves, the lower the pressure inside that fluid. The slower the fluid moves, the higher the pressure. The best way to look at it is with a demonstration all about Bernoulli's principle. So I'd like you to take out your demonstration booklets and write down the name of this demonstration, Pulling Soda Cans. And I'll play the video right here. Remember, at any point, just to pause this, mute it if you want. If you just want to write down the notes without me talking, that's fine. Maybe listen a little bit to what's going on inside the demonstration, but other than that, feel free to pause and go back at any moment. Okay, so here is our demonstration. We're going to start with two soda cans hanging straight down, just by some thin strings right here. All the air around them is not moving, which means all that air has the exact same pressure with no pressure difference. There's no push from high to low pressure, so nothing moves. You can write down your observations of any kind, but right now nothing's going on. Now I'm going to pop up in the background here. Yeah, it just looks strange. All right. And what I'm trying to say is I want the two to touch here, but I can't push right and I can't push left. But I want them to squeeze together and hit. Now, in order to do that, I'm going to use Bernoulli's principle. I'm going to make air move quickly around the cans in one position. Take a look. All I did is I blew right in between the cans. I'll stop it, show it again. Again, write down your observations. I'm not blowing on one can. I'm not blowing on the other can. I'm blowing in between them the best I'm able to. I'll try one more time. Now make sure you're actually just writing down your observations, what's going on, what you see, which can's moving more maybe. that's the demo right there. So after you've written your observations, we're going to go into the explanation. Go ahead and pause the video right here, but I'm going to move forward. Okay? So we have the two hanging soda cans, and they're surrounded by slow-moving air in the classroom. All the air has the exact same pressure, all right, but I want to create a force that makes the two cans swing together and actually touch. I know that without a pressure difference, there's no force that I'm going to be able to exert, so I don't want to push on either side. I want to use a pressure difference to bring them together, to pull them together. See, that's why I call them pulling soda cans. So what I did is I blew air directly in between the two. When I blow air in between the cans, the air in between the cans moves faster. According to Bernoulli's principle, the faster the moving fluid, the lower the pressure. So I have fast-moving fluid in the middle, slow-moving fluid on the outside, so I have high pressure outside, low pressure in between the cans, and there's a force that pushes from high to low, making them swing together. Okay, so again, Bernoulli's principle states that the faster air moves, the lower the air pressure, and a force pushes from high pressure to low pressure, causing the cans to swing together and touch and click real quick. And this picture should help. Alright, so slow air, high pressure. Fast moving air in between, where you blow in between them, low pressure. Force pushes from high to low, the cans swing together, and they touch. Alright, a simple, quick demonstration of Bernoulli's principle. Alright, when you're done, pop that away, take out your notes again real briefly, and we're going to move on. So Bernoulli's principle explains exactly where some of the force that lifts a plane into the air is actually going to come from. So we have our wing shape like we did before. The wings have a curve in the top, and they're fairly smooth and flat right here. The air moving at the bottom is moving at one speed, but because the air is being forced up over the top of this curved surface, the air actually increases speed, so the air moves a little bit faster over the top of the wing. According to Bernoulli's principle, the faster the moving fluid, the lower the pressure. So now we have a low pressure area right here. Alright, so we've got a low pressure right there. And if you got a low someplace, you have to have a high pressure another place. So we've got a high pressure right here. And we experience a force that pushes from high pressure to low pressure, and we even give that force a name. We call it lift. Okay? So, air moves faster above the wing, creating an area of low pressure. High pressure to low. High pressure will push to low, and we get lift. There are other places we can see this. Again, we have our situation with an airplane right here. But if you're a fan of baseball, if you're a pitcher, or you've ever watched somebody pitch softball or baseball, the way the ball is flying through the air has a lot to do with the behavior of the ball. Like if you were to spin the ball, all right? So as the ball is moving, air is moving this way, all right? If the ball is spinning in this direction, it creates an area of low pressure here. So this arrow, the red arrow right here, combines with these two blue arrows. You get faster moving air right here. The air moves faster. It has a lower pressure, all right? Pressure pushes with a force from high to low. So again, we're getting an overall force pushing down if you're spinning the ball correctly. And guess what? That ball, as it moves through the air, it's going to sink. So your batter is watching the ball come, they swing, and the ball is actually dropping down faster than gravity would normally pull it because you have this push from high pressure to low pressure. And they swing too high, you got a strike right there. Okay? Curveball, same thing. It's all about the direction the ball is spinning, creating a low pressure in some place and gets pushed towards that low pressure. It's a very cool thing that happens in baseball, but it also explains why, you can bend a soccer ball. Somebody can kick a soccer ball, looks like it's going nowhere near the goal, but somehow it's magically curving through the air and goes into the goal. Same idea. We'll take a look at that as well. Okay, I think that's plenty for right now. Make sure you write down a little bit of the notes. Make sure you take down that next demonstration. Remember, if I'm popping up a demonstration, it's really just a way for me to engage you back into the science classroom. It's not necessarily, oh, I've got to submit this particular thing. If I ask you to submit something, please do. But if I don't, just take the notes, get back into a little bit of a science mindset. Can't wait to see you guys again, and I'll talk to you later.